Your water system is designed to fail, not immediately, not obviously, but slowly, predictably, and expensively over time. The plastic tank you install today will crack, the pump will wear out, the pressure system will fail, and when it does, you won't question the system. You'll replace it, because that's what you've been taught to do. But what if the entire idea of how we store and use water is wrong? What if the most reliable water systems were already built thousands of years ago, and never needed replacing in the first place? Long before plastic, electricity, or pumps existed, civilizations were storing and distributing water with a level of durability that modern systems still can't match. Around 300 BCE, in the desert city of Petra, engineers carved massive underground reservoirs directly into stone. These weren't temporary solutions. They were permanent systems, lined with materials that resisted water seepage so effectively that some of them still hold water today, over 2,000 years later. No maintenance crews, no replacement parts, just gravity, stone, and intelligent design. The same principle appeared again centuries later beneath Constantinople, where an enormous underground reservoir supported an entire city. Hundreds of stone columns held up a vast chamber capable of storing tens of thousands of cubic meters of water. That structure still exists, still standing, still holding water after more than a millennium. And in ancient Jerusalem, engineers carved a tunnel through solid rock, channeling water into the city with precision that modern tools would struggle to replicate. That system ran continuously for thousands of years. These weren't isolated innovations. They were part of a pattern. Different civilizations, separated by geography and time, all arrived at the same conclusion. Water doesn't need to be forced. It needs to be guided, and when it is guided correctly, it doesn't require constant intervention. Now fast forward to today, and something doesn't add up. We have more technology than ever, yet our systems are weaker, shorter-lived, and completely dependent on external inputs. And that's where things get interesting, because the old knowledge didn't disappear. It just became rare, and one of the places it still exists is in plain sight. In Lancaster County, Pennsylvania, thousands of Amish families are still using water systems built on these same principles. Not because they lack access to modern technology, but because they don't need it. Their systems are simple, reliable, and incredibly long-lasting. Some families today are still using cisterns built by their great-grandparents. Systems that have been functioning for nearly a century without pumps, without electricity, and without the need for constant repair. And once you understand how these systems work, it becomes very difficult to ignore how different they are from what we use today. At the center of the system is something remarkably simple, an underground storage tank, or cistern. But unlike modern tanks, this one sits below ground, surrounded by earth that naturally stabilizes temperature. This means the water inside stays cool in summer and doesn't freeze in winter. No insulation required, no heating elements, just the thermal consistency of the earth doing the work. The second part of the system is collection. Rainwater, falling freely from the sky, is captured using roofing surfaces, typically metal, because it allows water to flow efficiently. Most of the rainfall is directed into storage, while the initial runoff, containing debris, is diverted away. No complicated filtration systems, just smart routing. The third part is where everything changes. Distribution. Instead of using pumps to force water where it needs to go, these systems rely on elevation. By placing the storage higher than the point of use, gravity creates pressure. Every foot of height translates into usable water pressure. No electricity, no mechanical components, just gravity doing what it has always done. And when you step back and look at the entire system, something becomes obvious. It doesn't just work. It keeps working, year after year, decade after decade, with minimal input. Now compare that to modern systems. A typical well setup requires drilling, electrical pumps, pressure tanks, and constant maintenance. Plastic storage tanks degrade over time. Pumps fail. Electricity costs add up. Over a few decades, the total cost multiplies far beyond the initial installation. And yet, this is considered normal. So the question becomes unavoidable. If a simpler system exists, one that is cheaper, longer lasting, and independent, why isn't everyone using it? The answer isn't technical, it's structural. Modern systems are built around ongoing consumption. They require parts, replacements, energy, and service. That creates an ecosystem of products and services that depend on continuous use. A system that works for 100 years without intervention doesn't fit into that model. It doesn't generate recurring revenue, it doesn't create dependency, and because of that, it doesn't get promoted, it doesn't get taught, and in many cases, it doesn't even get recognized by the systems that regulate building practices. In some regions, collecting rainwater was restricted or heavily regulated. In others, connecting to municipal water systems is mandatory, regardless of whether you have a working alternative. These rules weren't created randomly. They evolved within a system that prioritizes standardization and control over independence. At the same time, the knowledge gap widened. Traditional building methods were removed from mainstream education. Generations of builders were trained in systems that rely on pumps and electricity, while older methods quietly faded from common understanding. But here's the key point. None of that changed the physics. Water still flows downhill. Gravity still creates pressure. Earth still stabilizes temperature. And materials like concrete and clay still perform exactly as they always have, which means the system itself never stopped working. It simply stopped being used. And now, that leaves you with a choice. Because once you understand this, you realize something important. You don't need to replicate ancient cities or build massive underground chambers. You can apply the same principles on a smaller scale. You start by choosing the right location, ideally somewhere elevated relative to where you'll use the water. Even a modest height difference can create usable pressure. Then you build a storage system, something durable, sealed, and protected from environmental extremes. From there, you design a collection system that captures rainfall efficiently and directs it into storage. And finally, you connect it all with gravity. No pump, no complexity. Just a controlled path from source to use. Of course, details matter. Soil type affects construction. Water quality needs to be managed. Filtration can be added where necessary. But these are refinements, not obstacles. Because at its core, the system is simple. And that simplicity is what gives it strength. Over time, systems like this don't degrade in the same way modern ones do. They don't rely on components that wear out. They don't require constant input. They exist, function, and continue to function. And that's something we've largely moved away from. We've become used to systems that need us constantly, systems that break, that require attention, that demand resources. But this is different. This is a system that, once built correctly, steps back. It does its job quietly, consistently, reliably, just like it always has. And maybe that's the biggest shift of all, because this isn't just about water, it's about how we think about building. Do we create systems that depend on constant support, or systems that sustain themselves? For thousands of years, the answer was clear. Then we changed it. But the original approach never disappeared. It's still there, still working, still waiting. The only question now is whether you continue replacing what breaks or start building something that doesn't. If this changed how you see something as basic as water, subscribe. Because the next system we break down might completely change how you think about your home itself.